So what we had talked about yesterday, I think we got to this point where we were talking about we want to stay inside of the circle, but go outside of this cardioid. So this would have been our area. And what we were talking about when we were doing these is that if I'm going to set this up, the area in polar is always that 1/2 for a single curve. What we always did is 1/2 r squared d theta. But now that we have this in between two different curves, all that means is it's similar to our washer method where we need to take the bigger radius, which ultimately is kind of, if we look at this blue region, the outermost curve, because the outermost curve is going to have the bigger r, and then subtract the little r squared, and then the d theta. Let me write this further down here. So initially, hopefully, if we understand this is the outermost, when we look at this blue region, the outermost curve is the circle. That's the outside of that region. So the circle, I certainly don't need big parentheses to write a 1 in here, would be 1 squared. And then minus the little r, the one that's going to give you the smaller radii. That's the red curve, the cardioid, which is 1 minus the cosine of theta squared. And then our change in the angle. So then the thing that is missing then is what angles do we start and end that area with? Visually, you can kind of tell. We wouldn't want to just guess. The way we can identify for certain is by just setting those two equations equal to each other to figure out at what angle do we get the same radii. So as we set those equal, let's say we add the cosine over, so it becomes a positive cosine on the left, subtract 1 from both sides, we ultimately get cosine of theta equals 0. We think, all right, x coordinate of what angle is going to have a value of 0. So this kind of what we would have thought it would have been, that's at pi over 2. That's when we get a cosine value of 0. And then also 3 pi over 2 at the bottom. However, and this is one of the ones that would be on that quiz, because this is one of the easiest things to make a mistake on. Here's where we need to be careful with this. If I put my lower limit as pi over 2 and my upper limit as 3 pi over 2, think about what that means if we set up a little r theta chart. If I start with pi over 2, aren't I then going to like 2 pi over 3 pi, 3 pi over 2? Isn't that actually giving us all the radii over here? And that is not where this area is at. But if we do that, if we say pi over 2 and then 2 pi over 3 pi, 3 pi over 2 is giving us all of this stuff over here, and that's not what we are looking for. So what we need to do here is instead of calling this thing 3 pi over 2, we're going to call this negative pi over 2. Because if we now think about what this table would look like, if we now start at a negative pi over 2 and finish at positive pi over 2, don't we have to go to like 0? So we're going to be going negative pi over 2 and then 0 to pi over 2. Now this is going in the direction that we need to be going to get all the r's that would make up that blue region. So our limits then have to be the negative pi over 2 to the positive pi over 2. All right, does that make sense? The one on the quiz was like that. So the one that asked you to find the area between two curves, I definitely kind of tested and made sure people understood that if we were to have that quiz. All right, so now number 2, if we go to number 2, set this guy up. Same exact thought process. If we're going to do our area, we're going to do 1/2, and then we want the outer curve square. So if I now look at this blue region here, starting from the origin, the bigger r's are going to be found in the red curve. That's our outer curve. So that is the 1 minus cosine of theta minus the inner curve. So the inside or smaller r's for this blue region is going to be the circle. If we set these equal to each other, the exact same thing would play out, where you're going to get the cosine of theta to be a 0. But now if I say pi over 2 to 3 pi over 2, isn't that now what we want? Because now I am starting at pi over 2. I want to be going in this direction all the way around to 3 pi over 2. So this one, no tricks here. Those then actually are your limits. We would start this one at pi over 2, let this one be 3 pi over 2, and then that should be the setup to throw into the calculator. Okay. All right, follow that idea. Okay, then number 3. So use your calculators. Although the circle we should know r equals 6 is a circle. So let's sketch that in with a radius of 6. Actually, this one, if you were clever, we could do that without a calculator. Actually, go to graph that on your calculator. Because to graph that on our calculator, the reason I want you to try that is we can't throw the cosecant into the calculator, correct? So we would have to write this as its reciprocal. So instead of 3 times the cosecant, isn't cosecant 1 over sine of theta? So when I say we could probably do this one without our calculator, the reason for that is let's multiply this sine of theta over so that we now have r sine of theta equals 3. Remember how r sine of theta is really y? So if you did throw that into your calculator, that should be giving you nothing more than a horizontal line through 3. Okay. Then identify what we're looking for. We want to be inside of the circle, but then above what was ultimately that line. So this here is what we're looking for. All right, I'll give you a minute. Set this one up. This is the last one of these. Number 4 is just a regular area of one curve. So see if we can set that up after doing those first couple. All right. Outside, if we look at that yellow area, again, if you're going from the origin, we just want the bigger r's minus the little r's. So the bigger radii throughout all of these would be found, no matter where we're looking, with the circle. So the circle is the outermost curve. They have the bigger r's minus that. I'm going to rewrite it because if you're going to throw this into your calculator, you've got to rewrite it like this anyway. So you would want to have it written as 3 over sine of theta squared. And then our d theta. And then we now wanted to know what angle was this here. And then we wanted all the angles in between until we get this angle over here. So we should be getting a first quadrant angle. We should be getting a second quadrant angle when the 6 was equal to the 3 over sine of theta. So that ultimately what we're looking for is when does the sine of theta equal 3 over 6, which is 1/2. And in the first quadrant, the angle whose y coordinate is 1/2 should have been pi over 6. And then the pi over 6 angle in the second quadrant is 5 pi over 6. Okay. Fill that in the calculator, and then that should give us our answer. So that's how we do the area in between two curves. Certainly when we do this test next week, you're going to get one or two of those really, really common question. That's almost always one of the issues with the AP test is being able to do area in between two different curves with the polar. All right. All right. And then number 4, the reason I finish up number 4, this is a regular, and if you want to draw this, you can see you get some pretty wild graphs with these. So if you actually threw that into the calculator, it's a very pretty little flower. But what we just are dealing with is simply, again, the area of a polar curve is 1/2 of r squared times r d theta. R is the original curve. All right, goes 0 to 2 pi, and then that should give us then all of the r's that get us around that rose, that flower shape. Okay. All right, so then, as I was showing this stuff to you earlier, I realized I wanted to send a remind message. So if you wanted to get ahead and print this out, because this AP question is not in your packet. So let me pull this up, but you can find it. This is the one in our modules. If you did want to print it up at some point. This 2014 one. All right, so I'll pull it up here in a second. But if you've got a printer real quick, we're nearby. Well, it says 2017, this is 14. All right, we're going to do this question. All right, but that's where you can find it. So let me pull mine up. There we go. Because this is one where we've done a couple of problems now where if you look at these 3 different regions, pull this up. There's region 1, here's region 2, here's region 3. We just did a few problems where we could figure out region 1, outside minus the inside, and region 3 where we do the outside minus the inside. But what if we do that area in the middle? Okay, so that's what this one now gets at. And then there's one in the test review as well like this. If we have time today, we'll go over that. You guys have a little more time than 7th period, so we can look at that one as well. So pretty simple little setup. They tell you the graphs of the polar curves r equals 3, so we know this is the circle. And then r equals 3 minus 2 sine of 2 theta has to be the weird looking one. And they're shown the interval is 0 to pi. So now they come right out of the gate to find that area in between. So the easy option is, again, this area 1 or this area 3. They're asking you to find area 2 that's shared by them. So there's a couple different ways that we could approach this a lot of times. Here, there's definitely one nice way that we can go about it. What this typically involves is multiple integrals or multiple calculations. So if we understand how this is working, what I'm going to do, the easiest way I think for this one is let's split this right here. And isn't all the area over here enclosed by the circle? Yellow doesn't show up very well on this. And then isn't all the area over here enclosed by this 3 minus 2 sine of theta? So if we understand that, it's really just 2 separate problems. And as long as we know what our limits are, we're going to find the area of those 2, and then we just need to add those guys together. Okay. So that's what we're going to do in A. I'm going to do A up here just so we can see it. So I'll do it up here, and then I'll erase it. But you can do that wherever you need to do it. You might not have it printed anyway. So if I now go and find this area, and actually, couldn't we, for this circular part, we don't even really have to do this in polar, correct? Like we know this is 1/4 of a circle. So we really could do this with some simple geometry and just find 1/4 of the circle pi r squared. And that is going to be 1/4 pi. We know that this little quarter circle in here has a radius of 3. So the area of the circle is what? 9 times pi over 4. And then we're just going to add that to the area of this blue region. This is definitely not a circle. So now we really do need to do this with our little sector formula, where we're going to do 1/2 the integral, and it's just a single curve. So it's just r squared. So 3, let me make it a little bigger. 3 minus 2 sine of 2 theta squared. And then we need our limit. So write down what you think your limit should be, because you're probably right. It's not a trick here. And then there are ways to test this just to confirm what our limits would be. All right, my first guess is if we're thinking, all right, if this area starts here, I would hope most of us think that the lower limit is going to be angle 0. So just test that real quick. Take angle 0, plug it into this. Wouldn't this give you r equals 3 minus the 2 sine of 0? Sine of 0 is 0. 2 times 0 is 0. So that would tell us that our r is in fact 3. So that tells us, yes, that is correct. Then we're probably thinking then, since this occurs right here, we're probably thinking that this is pi over 2. So if we just want to confirm that, let's plug pi over 2 into that equation and see if it gives us this y value of 3 that it's supposed to be giving us. So r would equal 3 minus 2, the sine of twice pi over 2. The 2's are going to cancel. And then kind of think this through. Isn't the sine of pi, the y coordinate at 180, isn't that also 0? So you're going to get 3 minus 0. So that also gives us a radius of 3. That then tells us that those are in fact our limits, 0 to pi over 2. Okay. This was a calculator question, the first 2 questions. So this is question number 2. The first 2 questions are calculator questions. So then they're definitely allowing you to throw this into your calculator. The quick little math 9. I don't know what it is individually, but when I did it earlier today, should get this overall for that area, 9.708. If we have time, we'll do the one on the review too, because that one's even different than this one. All right, you need to be creative when they start giving you that area in the middle. All right, so Lily, hopefully that helps a little bit. Lily was asking about what happens if we get that middle one, and that's one example of that. All right, letter B is the other reason I wanted to do this question. Really, really common question. It's kind of hidden what they're really asking you for. So they're still dealing with the original function that you're given, and they're asking you to find dx d theta. So understand what that means. That means ideally what we would have is like, let's say x equals 2 plus sine of theta. Since I have x's on the left, theta's on the right, if I took the derivative right now, this would be dx. I want to do it in terms of theta because that's what I have over here. And I would get the cosine of theta. That would be the answer. But the only way I'm going to get dx d theta is if I have x's on the left and theta's on the right. If you look at your equation that you're given, we don't have x's on the lefts. So this is a little hidden way of testing you on your conversions. So B we'll do down here. So if I do r equals 3 minus the 2 sine of 2 theta, if I want this to be dx over d theta, I want nothing but x's and thetas in this problem. Nothing but x's and thetas in this problem. Oops, I should move this. So remember how x is equal to r cosine of theta? That's what they're getting at here without coming out and saying rewrite this polar equation into Cartesian or back and forth. So now what that's going to allow us to do, solve this for r, so that r is equal to x over cosine of theta. And what we're now going to be able to do is to get rid of the r right here and replace it with an x over a cosine of theta. And then hopefully we're kind of seeing what would be the next step, kind of on down the line here, how this now needs to play out. If I now solve this equation for x, so take that 3 minus 2 sine 2 theta, and then multiply that cosine of theta over, can't I now take the derivative and now get the change in x compared to the other side's change in theta? And we now have the variables that we need. Okay. So first, we understand that idea. Second thing then, yes, we want to do the derivative of this, but like I mentioned, with this being question number 2, this was a calculator question. So while you should be able to do the product rule here along with a chain rule in here, you should be able to do that by hand. They're really wanting you to use Math 8. There's a reason that that's one of the 4 functions that they allow you to use. So they're really, and don't not use Math 8 because it's hard to mess up if you use Math 8. You're just going to take the derivative of this expression. What value did I give you? Or they give you pi over 6. And then we're going to evaluate it at pi over 6. So I'm going to say dx d theta at pi over 6. And then we just let the calculator do the work for us. I think I had that. Oh, I already have it because I did this earlier today. Make sure I remember how to do all these problems. Sometimes these things make me think a little bit. So you do the dx or Math 8. You throw this in, and then this should be your answer, right? The negative 2.366. Right, and then this, yeah, this here. So we look at this, should be the answer that spits out. There's another one of the AP questions that I have on that test review. It's another one like that, where it's just kind of subtle, and they don't come out and say this is what they're looking to do. You just have to kind of piece it together with those variables. Okay. All right. So it was the negative. What was it? Negative 2.366. Right, and then that's our answer. All right, letter C. It says the distance between the two curves changes between the interval of 0 and pi over 2. So what that simply means is this area in here, the distance between them is changing. It's getting longer and longer and longer in this interval, and then the distance is going to get smaller and smaller and smaller. But between 0 and pi over 2, the distance between those two curves is getting smaller and smaller. So this is now saying find the rate at which the distance between the two curves is changing with respect to theta at the angle pi over 3. They're really clever. I give them a lot of credit. I like actually seeing their questions every year to see sort of what they created to make you think on your feet a little bit. This has just turned into a related rates problem from the beginning of, from like October of last semester. When it's talking about the rate at which the distance is changing, that's one of those related rate questions. So what we need to set up first is we need to first write an equation for the distance between these. So do that real quick. Make sure we can do that. That hopefully is a reasonable thing to do. So write an equation for the distance between those two curves from 0. Let me show you the graph because you kind of need to know the graph. From 0 to pi over 2. Write an equation for the distance between those two curves. All right, so hopefully as you did that, we understand that the distance always is taken from the origin when we're in polar. So the distance between these would be the outer curve minus the inner curve. So it's really just the circle minus, well, I don't know what you want to call that, but the 3 minus 2 sine of 2 theta. So the distance is 3 minus, what is that? 3 minus 2 sine of 2 theta. I'm going to simplify that a little bit. So D equals, if I distribute that negative, notice how the 3's would cancel. And then I would get a negative, -2. So it actually simplifies nicely to just be 2 sine of 2 theta. And then if we want the rate of change in our distance, that's really just looking for dd. And then this is now in terms of the variable theta, dd d theta. You could use your calculator again. I would actually tell you to use your calculator. This one, though, is much more reasonable. Like, we better be able to do this derivative pretty quickly, even though I just started to mess it up. You would initially get 2 and then cosine of 2 theta times 2 again. So this is a pretty simple little derivative to take, but don't risk it. Use the math 8 key on that day. And then you're just going to evaluate it at pi over 3. And again, don't be doing this work. You know, right now, just throw it into math 8. All right, do it on the calculator. But when we do that, it should ultimately give us, did I screw up? Oh, it's a -1/2. Yeah. It should give you a -2 for your answer. Okay. All right, and then letter D. D is actually the one that I was referring to as the related rates. This letter D says a particle is moving along the curve, and they again give you the original curve. That's the weird looking graph up above. 3 minus, come on. There we go. 3 minus 2 sine 2 theta. But then look what they now give you. So let me go back up to this original problem because some of you don't have this here. They give you that d theta dt. Notice how there is no t right here. There's no t anywhere. But d theta dt is going to equal 3. And then they want you to find the value of dr dt at the angle of pi over 6. All right, this is the one that I'm talking about. Remember all the related rate questions? Whenever we did those, I always told you that we want to take the derivative of the equation. Why is this not working here? With respect to time. That's what they're now telling you to do. So if I did the derivative of r, I no longer get dr d theta. I would have to get dr dt. And then on the right-hand side, the 3 will go away. I will get initially a -2 cosine of 2 theta times. And then when we do the derivative of the inside here, it's not just a 2 anymore. It's a 2 d theta dt. If you've started making any headway on those review videos, I think this is that third review when we kind of did all those related rate questions. All right, when you're always doing the derivative with respect to time, that's going to be your answer then. Well, not your answer, but that's going to be your equation that you're going to plug into. So now we evaluate this. So find this at, what time did we get? Pi over 6. And again, you have your calculator. So if you're thinking this is a big unit circle question and you don't like the cosine of 2 times pi over 6, just throw it in the calculator. And then the reason that they gave you, because we're not given d theta dt, or at least we don't know what it is, but that's what they gave us up here. D theta dt was equal to 3, and it's for us to now plug that 3 in. And then whatever that is your answer. And honestly, leave this. I should say that. You can leave this. Free response, if you wanted to leave that guy, all right, that's a completely acceptable answer. Now, we should be able to simplify that to -6. but that's her answer. So fun little question there. I like that one. All right, let's see here. You know what? We got a little time. Go to your test review. So let me pull up that. I'm pretty sure I gave you one of these. So go to your test review. It's on the back. You should see 2 polar questions. Find the polar question that's asking you to find the area between the 2 curves. So let me get this up here. This one. So the very first one, the one that has the number 3 right here. Similar setup. If I gave you those numbers 1, 2, and 3, they give us the harder one, the one in the middle. Take a minute because I'm going to copy and put this on a Word document so I can write it a little bit easier. See if you can do letter A, because letter A is asking you to find that shared region in there. So see if you would have a plan of attack in order to be able to do that. And don't look at the answers below. Don't cheat, because I think I have the answers there. Okay. So there's 2 ways that we can now approach this. I don't know if we'll get through them, but let's see if you've thought one of these 2 ways out. Let me just do it up here. So option 1. Option number 1 is the one that I think is nicest. Option number 1, let's say we just had all of this circle shaded in, right? We know how to find the area of a circle. And in this case, it would be pi. The radius of this, if we look, since it's r equals 2, was 2 squared. That's the area of the entire circle. So if we just had the circle, that would be our answer. But don't we then want to get rid of this area right here? Like we don't want this. So we want to subtract away we'll call it the polar area. Then this is now what we just got done doing in our notes. I want to now set up a question where I'm going to do 1/2 of the outer curve, which is the circle, and let's subtract away the area of the inner curve, which is this 3 plus 2 cosine theta. They're very, very nice because they actually tell you where these intersect. 2 pi over 3 to 4 pi over 3, so that was nice of them. Those are your limits. Wouldn't that then get rid of this blue area? And if that then gets rid of the blue area, so magically there it's gone, wouldn't that then leave us with everything that's in between? All right, so that's option number 1. We probably don't have time. We'll have a little time tomorrow as we go over the review, but there is a second option. So if you're thinking that is not what I saw, you want to try something a little different, maybe that was your option, but we'll have to do that one tomorrow. Okay, and then we'll just kind of see how you do that. So when it gives that shared region, it's definitely a little bit harder. Okay. Okay, so with that, we'll do the review tomorrow, and then no quiz. If you want to look at the quiz, though, I put that on Canvas as a little just guide if you want to kind of see what sort of things I would expect you to be able to do. And then just plan on taking a test on all of Chapter 10 on Tuesday of next week. All right. And then you have homework tonight. Let me not forget that. Also, that's due tomorrow. So if you have any questions on that, check in with me second period tomorrow. A, B, and C in that question, I think you're going to find very nice. D, sometimes there's some questions on that one. But if you need help, just let me know in the morning. Okay. All right. If there's a bell, it would be ringing right now. So we'll see you guys. Have a good day. All right. See you tomorrow.